Assalamu alaikum, bismillahirrahmanirrahim. Bishrali sadri wa salimi wa hlul uqdatam min lisani yafqahu qawli. Well, today we will cover experiment number 1 and 2, that is related to stone vapor boiler setup, operation and its water system. This is a stone vapor incident. I hope you already seen the initial video capturing the whole setup of the steam boiler, superheater, turbine and condenser. Well, right now, before that, I will share some of my experience related to this boiler and my past industrial experience of boiler. Well, in mechanical engineering, boiler itself is a industry, and by graduating from this university as a mechanical engineer, you can opt this as a profession too. You have to clear second class boiler engineer exam, then first class engineer exam, then you will able to become a boiler engineer. I don't know where this picture has gone. Well, itself is industry and it's come under the government of Sindh Director of Industrial Industries. This is their office, and we have a boiler inspection wing in Sindh, all over the Sindh. And as well, we have two division in Sindh covered by this government of Sindh, and in Punjab and rest of the other parts of the country, the boiler division done by the Punjab government, that is for federal government. So we have two different institute of government that running this that's looking after whole operation of the boiler and their inspection, etc. So currently our university boiler is water tube boiler. It is also every year it is also inspected by boiler inspector, and it is registered under the boiler operator, uh, Mr. Danish. It has a overall area of heating capacity is very low, so it's registered just on boiler operator. But if we have a bigger boiler like more than 10 ton, 20 ton or 50 tons, we need a boiler engineer to register on their name. As I just showed hit certificate, this is certificate of competency, second class boiler attendant, but we are going to become a boiler engineer. I also registered give registration to of this boiler examination, but still Sindh government didn't execute paper for the second class boiler engineer, but it hopingly they will cover in coming February. So I will also give this second boiler engineer exam just to increase my competencies or having a certificate. If I already have experience like 5 to 6 year experience in boiler operation maintenance, so I should go for the competency exam. Anyway, this is about the field of boiler engineer in mechanical scope. Now move towards Now moving towards our own boiler. I hope you all watched the detailed video regarding its setup. We'll come towards its experimental book, practical workbook. Mm. Well, this boiler, I have some experience with this boiler. This boiler has been shut down from the last 8 years. It is not in operation condition. When I come into the join Kennedy University, I was Dr. Mubashir make me in charge of this lab. So I just check all these the basic safeties of the boiler, and then rectify whatever the problem it has. One problem it has, this valve is not operating, that's why it is not coming into the operation. So I just open this valve first, I check all the things, then I just rectify this valve is not opening, that's why the boiler is not running. So I open this valve and rectify it. I have this video too. Yes, this is basically an add valve for the natural gas. When it just open, the gas is able to go into the boiler and fed the firing. So now and we also make video of this operation uh, that will be in that already shared with you people. Anyway, move towards move towards this experiment. A parrot is already described, but here's a sketch of the boiler. This is main control panel. The video is also showing the inside of the circuits. This is a steam exit valve, though two safety valves and main outlet valve. This is the pump section, and this is the water regulator. This is the water relief valve. This is the oil pump. Okay, now come to the section view. uh, as you already watched the video, the gas is fitted with the orange line and it is fitted in that position. When the air is passing from this point, it's making a vortex, and here we have a multiple burner over here, so it mixed with the air, and we have also igniter flame tube here which ignite the over main burner, and this exhaust valve or exhaust gases move towards downward, and by and from the bottom it again move up and exhaust from this position. So it comes into the contact with that boiler, which comes in the last position. The water come initial in outer pipes, then it moving towards inside pipe, and when it's completely heated, it's directly contact with the exhaust gas, so it becomes a saturated steam. So it's, you can assume that it is a counterflow heat exchanging. Means that exhaust gases in coming in this direction, and water coming in this outer pipe, so it is in opposite in direction. So water and gas is opposite in direction to have a maximum heat efficiency. Cross flow and counter flow heat exchanging is best rather than parallel flow. So it's a, you can say that it's a counter flow heat exchanging. Anyway, well, this is section view which I have described. Now coming towards the its water flow, the water is coming from the initial feed water tank, and as well as the return water coming from condenser. So the pump suck the water and push toward the servo control. So after servo control also control the water, the amount of water just that needs to go into that boiler. So that after that boiler, the boiler goes into the heat exchanger that I show in the video. Here we have a heat exchanger. Heat exchanger, basically we are preheating the boiler, preheating the feed water with our condensate steam. You see that condensate steam. So the feed water is heating with the some of the steam which is coming from the exit of the exhaust steam separator. So it's preheat water, like we have temperature like 37, so it becomes 90 sorry 86 87 something like that, depending upon the quality of the steam. If we have a fully saturated steam like 200 at 10 bar pressure, we have around 200 degree centigrade. So then we have a 85 87 and 90 degree water for the feed water. Then water goes to here. Okay, then this is the water circuit, and steam is coming out at the coming steam is exiting from the steam separator, and some of the steam goes into the steam trap. Steam trap is doing that, it uh, the amount of steam which is dropped due to the quality is goes back to heat feed water. मीन्स कि जब हमारे पास स्टीम सेपरेटर में आती है, तो स्टीम सेपरेटर का काम क्या होता है कि वो क्वालिटी जो जो रिक्वायर्ड क्वालिटी ऑफ स्टीम है वो लिफ्ट हो जाती है, और उसके अंदर जो कंडेंसेट होता है वो नीचे ड्रॉप हो जाता है. वो जो कंडेंसेट वाटर होता है वो देन हमारे पास यहाँ पर आता है, एंड देन इट इट और ये फिर ये फीड वाटर को हीट करता है, ताकि जो कंडेंसेट आपके पास जा रहा है वो भी अपनी एनर्जी लॉस ना करे, वो फीड वाटर को हीट अप करने में इस्तेमाल हो जाए. ठीक है, एंड देन जो फर्दर कंडेंसेट यहाँ पर कलेक्ट होना शुरू हो जाता है, वो देन हम स्टीम ट्रैप के थ्रू निकालना शुरू कर देते हैं यहाँ पर, ठीक है। ये सर्किट कवर हो गया। देन देयर इज इंटरनल डायग्राम ऑफ पम्प। इसको ज़्यादा डिटेल पढ़ने की जरूरत नहीं, बिकॉज दिस काइंड ऑफ पम्प ऑल्सो ऑब्सोलीट in our current boiler industry. This is basically a reciprocating piston type pump. This is servo control mechanism. Just I show that servo control mechanism is controlling airflow, water flow, and gas flow, natural gas flow. Here we have a picture, and also we have a video of servo control mechanism. It is running through. It is. Don't have video. This basically servo mechanism. It is directly running through a hydraulic coil and linked with the natural gas, linked with the this this blower, air blower, and as well as the amount of water as shown in the not amount of the water, but it according to this position it is controlling the water by water regulator. Okay. Now we have heat exchanger. As I told that the incoming water to the boiler is further heated by the condensate steam that coming from the steam separator. The water is coming in the shell, and in the tube we have a condensate steam that coming from the steam separator. This is water relief valve. Water relief valve is simple. When we have a reciprocating pump, so we set the pressure at some point like 5 8. If we need to set the boiler pressure up to 10 9 bar, we have to set the pressure around more than 10 bar, 11 12 something bar. And if the amount of steam is stopped at the exit of the boiler, so the overall pressure rise. So when the pressure rise more than the set point, the water relief valve open and the water recirculate inside the pump. Here I just left this water bypass regulator. This is water bypass regulator. When we have pressure more than the set point, the water relief valve open here and it recirculating the water inside the pump here in this way, because we don't have control as further controlling mechanism. Because if the steam valve is closed, like the requirement of steam is almost done, it is not requiring any procedure, so the overall line pressure becomes pressurized more than the set point. So if we do not have a water bypass regulator, the piston is continuously working. Okay, we do not shut down the pump, so it breaks the pipes. When the pressure rises its breaking point, it's breaking the pipe of the boilers. So that's why we have a bypass regulator. So it circulate and surrounding the pump, like it exit from the pump, goes here and then again sucked into the inside line, so it recirculating and maintaining the set point. Anyway, this is all about the water circuit. Come towards the steam circuit. In the steam circuit, we have a steam temperature limit switch. That is a limiter switch. If we have a more temperature than the set point, it shut down the boiler. Okay, it continuously sensing the temperature of the steam. Okay, the steam is going toward the steam separator. It is a vortex type steam separator. Okay, the steam is flowing. We have a cut view diagram of steam separator over here. Yes, the steam is coming from here. It circulate surrounding the wall, and then from the bottom it goes upward to the exhaust. This is the exhaust of the boiler, and parallel to this we have two pipe with the exhaust pipe for the safety valve. This is safety valve. And you see that there's no wall connected with the safety valve, because if the wall is connected with the safety valve, it is a fundamental law that on the safety valve we don't have to install any control valve, any stop valve, because if someone intentionally close the valve and the boiler temperature rise, it can explode. Okay, there's a huge loss of the human lives and the surrounding and the money and all risk criteria that contains with the boiler, because it's a pressurized thing. Okay, so we always directly connected a safety valve with the line pipe, and after that we have a valve to control the steam flow whatsoever, and it's operate only when the temperature rises more than its set point. Like we are in our boiler we have a working pressure like 11 bar, so we set this safety valve around 16 bar. Okay, so this is the steam circuit, the steam coming from the boiler. You see that in this boiler we don't have any water drum or steam drum. Okay, so we don't have a collection of steam system, so the steam already contains some liquid, some moisture. So by passing through steam separator, all the moisture drained in the downward. Okay, and the pure steam coming over here, and we have a steam gauge pressure which telling the steam pressure. I already show in the video. You see that this is steam pressure gauge. Here we have different gauges. Okay, now coming to the steam trap. Okay, what is the function of steam trap? The steam coming from the boiler is coming toward the steam separator, and from the bottom of the steam separator the steam trap is connected, because you see that if the valve is continuously open or if the valve is continuously closed, the condensate collect in the steam separator, and ultimately it can again goes with the steam. So to drain out the water, to drain out the condensate in steam separator, we have to have a steam trap that automatically drain the condensate of the steam. So the liquid condensate coming from the steam trap is leveling in this inverted bucket steam trap. There are many type of steam trap. Here we are only covering the bucket inverted bucket type stream trap. So you see the phenomena of inverted bucket. The inverted bucket is placing over here. When the level rise, the inverted bucket it's filled with the steam. Here we have steam or air, whatever the gases form. So when the liquid rise, this inverted bucket also rises, and the link between the inverted bucket also pull. When it come to that position, this valve is open. Okay, and we have a pressurized steam over here. So pressurized steam coming over this point. Oh, sorry, I'm just confusing you. In this inverted bucket steam trap, the water is collecting in this position. Like this is the inlet position. The water is connected. The water is rising with the condensate, and you see the density of water is less than the steam. So steam is always taking place upside. But when the level is rising, the inverted bucket also rises, and when this valve is open, this valve is become open. So by the pressure of steam, the condensate collecting in this steam trap is moving to outside of the steam trap. You can see that many videos in YouTube about the working principle of steam trap. They have animation how the condensate is coming inside the steam trap and leaving the system. Okay, now this is the safety valve. Safety valve is simple spring loaded valve. We have a spring coil connected over here that continuously exerting the pressure in the piston over there, and it has some elastic force. Okay, we have some elastic force, and this elastic force is just equal to set pressure. Like for example, if the pressure rises more than 16 bar, the pressure from this point, the steam is coming from this point. Okay, so it is this force will be more than the force is exerting on this area. You can simply find out the force that we have a pressure like 16 bar, and what is the formula of pressure is equal to force upon area, and we know the diameter of this piston, so we can calculate the force. When the force is more than this elastic force, this piston opened, and the excess pressure of the steam releasing from this point, from this channel, and when the steam pressure becomes normal, then the elastic force, due to the elastic force, the piston closes the valve again. You can see that before operating this boiler, this boiler that has been closed from the last 8 years, I also inspect the valve. I have video over it. This is the testing video of steam trap. We can also check the steam trap by, they have a valve, manual valve, which through which you can manually open this valve too. Right, in this video we are manually opening, and in this video we are filled this boiler with the water only, not steam. We always test this safety valve with initially with the hydraulic pressure of the water. So you can see that this valve is open automatically at our set point. I also noted pressure. You see that at 9 bar it is opening. I set the pressure at 9 bar. So but the thing is that I'm just checking the safety valve before coming into the operation by using hydraulic pressure of water, not steam. Okay, this is actual safety valve. You see that it automatically opens and releasing the excess pressure. You see that this is the video of from General Tire, which I was doing, working as a utility engineer over there. Anyway, let's move towards the air and gas system. You see that the single motor connected with the pump with the belt and pulley, and with the belt and pulley it is connected with the boiler, so, with blower of the air. This is a blower, and inside the blower we have this impeller, which is pushing the taking fresh air from outside and releasing from this channel to the inside boiler combustion chamber. Okay, so the motor is connected with not three things: pump, hydraulic pump for the lubrication and controlling the servo mechanism, and blower. This is the internal parts of the burner. You see that by gauge glass, you see that this holes and nozzles, we can easily watch these holes and nozzles, and they are firing the gas in this video. I also, you already seen this in previous pictures too. You see that this is the nozzles, it is burning. Yes, these are the nozzle which are burning the gas inside the combustion chamber. Okay, so in this assembly we have three different things. We have a spark plug. Initially the spark plug ignite the flame tube, just like our geyser. We have to run the geyser, we have to run the pilot before the actual burner. So in this case the pilot burned by this is sparking plug system. So spark plug system run this pilot burner, and viewing flame detector detects that when it successfully uh, burn the pilot is running successfully, then it opens the valve, hydraulic valve which I have shown in the video. These valve, okay, these valve, this valve and this valve, and I already told the purpose of two valves, not a single valve. So when the flame detector detects that the pilot is working or running successfully, or running the flame is right, by detecting its flame light, it's open the valve, and the main gas coming from this pipe to different nozzles of the gas, and this gas nozzle run the burning. This is basically the main burner. By this burning we have a saturated steam. Okay, then we have a hydraulic pump. As you told that the oiling system, the pump is stalled along with the water pump, draws oil from the oil tank. Pressurizer system maintain the bypass excess oil to discharge oil pump. Using the oil pressure, regulate the returning to its oil tank through the cooling coil mount in front of the ear. Okay, so we have also have a cooling mechanism of the oil, because in this it is clear. I already showed you the cooling mechanism of the oil, the inside channel of the blower. Well, we already know the purpose of the oil and the oil circuit. We have a hydraulic oil tank that comes to the oil pump. Again, in this oil pump we have a pressure relief valve to recirculate the oil if we have enough pressure. Okay, then it goes to the servo control mechanism that controlling the servo of oil fuel ratio, controlling the amount of air amount and the gas amount to have a accurate burning as per our requirement. This is the oil pressure regulator. It's regulating the pressure of the oil. Anyway, I hope I just cover detail experiment number 1 and 2, but you have to read out the whole theory of the experiment number 2 in order to solve all the question answer in this experiment. Okay, now this is all about experiment number 1 and 2, and all the boiler thing. I missed any video. I just cover video. This is the option of the video, because the steam is going over the steam header, so you can see that it is steam. In this video we are seeing that boiler is running at 10 bar, not 10, it's 9 bar. Okay, this is all about a stone vapor boiler. Let's meet in the next experiment video of experiment number 3.